Beneath the surface of our ever-changing planet, immense geological forces are at work, sculpting the land in ways both dramatic and subtle. Iceland, perched at the intersection of the North American and Eurasian tectonic plates, is a living testament to the restless energy of the Earth's crust. Here, glaciers and volcanoes coexist in a landscape defined by extremes, where ancient ice carves through valleys of solidified lava, and black basalt beaches meet the frigid Atlantic. Deep below, the Earth's mantle pulses with heat, driving plumes of molten rock upward. These plumes accumulate in vast magma chambers, reservoirs of liquid rock that feed Iceland's volcanic systems. The surface reveals this hidden energy through steaming vents, bubbling mud pots, and the constant exhalation of volcanic gases, evidence of the ceaseless movement below. Iceland straddles the mid-Atlantic ridge, a vast underwater mountain range where tectonic plates slowly drift apart. As the plates separate, magma surges upward to fill the gap, creating new crust and fueling eruptions. This dynamic process gives rise to a variety of volcanic formations. Shield volcanoes, with their broad, gentle slopes, are built by successive flows of fluid basaltic lava. In contrast, stratovolcanoes rise sharply, their steep profiles formed by alternating layers of ash, tephra, and viscous lava. The products of these eruptions are as varied as the volcanoes themselves: dense basalt, glassy obsidian, and lightweight pumice, each telling a story of temperature, pressure, and chemical composition. When pressure within a magma chamber becomes too great, the crust fractures, unleashing fountains of incandescent lava. These fiery rivers carve new paths, reshaping the land in a matter of hours. Sometimes the collapse of a drained magma chamber forms a caldera, a vast, sunken depression that may later fill with water, creating a crater lake shrouded in mist. Over time, cooling lava can form striking geological features: hexagonal columns of basalt, intricate lava tubes, and vast fields of solidified flows, each a testament to the forces that shape them. Volcanic eruptions also send plumes of ash and gas high into the atmosphere, influencing weather patterns and, over millennia, even giving birth to new islands as lava cools and solidifies in the ocean. Within the cooling magma, minerals crystallize in intricate patterns. Olivine, pyroxene, and feldspar settle out, their arrangement revealing the history of each eruption and the chemistry of the mantle below. The interaction of volcanic gases with surface water and rock creates vibrant mineral deposits, sulfur iron oxides, and silicates, painting the landscape in hues of yellow, red, and green. Over thousands of years, repeated eruptions build up plateaus and mountain ranges, while wind and rain slowly erode the hardened lava, sculpting the land into a mosaic of peaks, valleys, and plains. The true engine of this transformation lies deep within the planet. Convection currents in the mantle drive the movement of tectonic plates, while seismic waves ripple outward from each eruption, echoing the planet's restless energy. Every rock, every formation is a record of the Earth's inner workings, a chronicle of heat, pressure, and time written in stone and glass. In Iceland, the interplay of fire and ice is on constant display. The aurora dances above cooling lava, and frost forms on rocks still warm from the last eruption, a vivid reminder of the planet's dual nature. The rift valleys and fissures that scar the land are not scars of destruction, but signs of creation, evidence that Iceland is a land forever in the making, shaped by the relentless forces beneath. Each layer of ash, each band of tephra, is a page in the geological history of this island, an unbroken record of eruptions, flows, and transformations stretching back millennia. The chemistry of Iceland's volcanoes is as complex as their forms. Magma from different sources can mix, creating eruptions of varying intensity and composition, each with its own unique mineral signature. As dawn breaks over the volcanic heart of Iceland, steam rises from countless vents, and the land continues its slow, inexorable transformation, a living laboratory of geological processes forever evolving. Iceland's volcanic heart is not just a local phenomenon, but part of a global network of hotspots and rifts. Its features echo those found on distant worlds, offering a window into the universal processes that shape planets across the cosmos. To fully grasp the extraordinary volcanic activity of Iceland, we must journey far beneath the Atlantic Ocean's surface, where the planet's crust is in constant dynamic motion. Deep below, the mid-Atlantic ridge stretches like a vast underwater mountain chain, marking the boundary where the North American and Eurasian tectonic plates are slowly diverging. This ridge is a classic example of a divergent plate boundary, where the lithosphere is being pulled apart by immense geological forces. As these plates separate, magma from the mantle wells up to fill the gap, solidifying to form new oceanic crust. This process, known as seafloor spreading, is responsible for the continuous renewal and expansion of the Atlantic Ocean basin. Uniquely, the mid-Atlantic ridge emerges above sea level at Iceland, exposing the raw mechanics of plate tectonics in a way rarely seen elsewhere on Earth. Here, the rift is visible as a series of fissures, valleys, and volcanic features that cut across the island. The plates move apart at a rate of about 2 centimeters per year, a process so gradual it is almost imperceptible, yet over millennia it dramatically reshapes the landscape. This relentless divergence generates a network of deep fractures and rift valleys, providing direct conduits for magma to ascend. The constant tension and fracturing of the crust result in the formation of dikes and sills, sheet-like intrusions of magma that propagate laterally and vertically through the brittle lithosphere. These features are fundamental to the creation of Iceland's extensive volcanic systems. Volcanic eruptions in Iceland often occur along these fissures, producing spectacular displays of lava fountains and extensive lava fields. These eruptions are direct manifestations of the ongoing tectonic divergence beneath the island. Beneath Iceland, a powerful mantle plume, an upwelling of abnormally hot rock, rises from deep within the Earth. This mantle hotspot is stationary relative to the moving plates above, providing a continuous supply of thermal energy and molten material. The interaction between the mantle plume and the diverging plates amplifies volcanic activity, generating vast quantities of magma and creating one of the thickest sections of oceanic crust on the planet. This unique geological setting results in a landscape marked by frequent eruptions, geothermal activity, and the continuous formation of new land. Iceland is a living laboratory for the study of rifting, volcanism, and mantle dynamics. Over millions of years, repeated eruptions and lava flows have constructed the island layer upon layer, with each event adding to the geological complexity and youthfulness of the terrain. Much of Iceland's surface is geologically young, with vast expanses of fresh basaltic lava and rapidly evolving landforms. The ongoing interplay of tectonic and volcanic processes ensures that the island's geology is in a constant state of flux. The Reykjanes Peninsula, for example, is a product of recent geological activity, with its landscape shaped by eruptions and rifting events that have occurred within the last few million years. New land continues to emerge, as seen with the birth of Surtsey Island in the 1960s. A striking example of how volcanic forces can rapidly create entirely new land masses above the ocean's surface. The land remains restless, shaped by the ceaseless movement of tectonic plates and the deep heat of the mantle plume. Iceland stands as a testament to the power and complexity of Earth's internal processes, a vivid, ever-changing record of the great tectonic dance. The Reykjanes Peninsula's current eruptions are the latest chapter in a saga that stretches back millennia. Iceland's volcanic history is written in stone, ash, and the very shape of its land, a testament to the relentless forces beneath the surface. Geological evidence reveals that Iceland's landscape has been sculpted by a series of powerful volcanic cycles. These cycles are marked by alternating epochs of dormancy and intense activity, each leaving a distinct signature in the Earth. Deep beneath the peninsula, the mid-Atlantic ridge splits the island as the North American and Eurasian tectonic plates drift apart. This rift is the engine of Iceland's volcanic life, generating immense stress and opening pathways for magma to rise. Over centuries, volcanic ash, known as tephra, settles in layers, each one a record of a past eruption. By analysing these layers, geologists have reconstructed a timeline of Iceland's fiery past, revealing patterns of eruption and calm that repeat over hundreds and even thousands of years. The Reykjanes Peninsula, in particular, has experienced cycles where centuries of tranquility are shattered by decades of relentless volcanic activity. During these active phases, fissure eruptions tear open the earth, releasing rivers of lava that reshape the land. The 13th century Reykjanes fires stand as a dramatic example. For 30 years, a series of fissure eruptions blanketed the region in lava and ash, building new landforms and altering coastlines. The evidence of these events is preserved in thick bands of tephra and vast hardened lava fields that still dominate the landscape today. Modern scientific techniques, such as radiometric dating and geochemical analysis, have confirmed the timing and scale of these ancient eruptions. Each layer of volcanic rock tells a story of magma composition, eruption intensity, and the direction of lava flows. The patterns of lava flow across the peninsula reveal how each eruption phase has contributed to the evolution of Iceland's terrain. Some flows have travelled for kilometres, filling valleys and creating new plateaus, while others have built up the rugged, fissured highlands that define the region. The mechanism behind these cycles is rooted in the slow, inexorable movement of tectonic plates. As the plates pull apart, stress accumulates in the crust, eventually fracturing the rock and allowing magma to surge upward. This process repeats over centuries, driving the rhythmic pulse of Iceland's volcanic life. For nearly 1,000 years, the crust beneath Reykjanes held firm, containing the pressure and allowing the land to stabilize. Moss and soil slowly reclaimed the old lava fields, and the landscape appeared at peace. But the geological clock never stops. As strain built up once more, new fractures formed, and magma began to rise again. The current eruptions are the natural release of this pent-up energy, marking the start of a new cycle. The landscape is now in flux. Fresh lava flows cool and harden, creating new ground and expanding the coastline. Steam and gas rise from fissures, signaling the ongoing transformation beneath the surface. Scientists predict that this renewed period of volcanic activity could persist for decades or even centuries, with alternating bursts of eruption and quiet. Each event will add new layers to the geological record, further shaping the peninsula's future. Iceland's ancient volcanic cycles are not merely destructive, they are creative forces, continually renewing the land. The evidence lies all around, in the black sands, the jagged lava fields, and the ever-changing coastline. The Reykjanes Peninsula's fiery awakening is a vivid reminder of the Earth's dynamic nature and of the powerful cycles that have shaped and will continue to shape Iceland's extraordinary landscape. Across the Reykjanes Peninsula, the relentless advance of lava has become a force of nature that reshapes the very land itself. As magma surges upward, the ground swells and splits, releasing plumes of steam and heat that warp the landscape. Great fissures tear through the earth, carving new scars across ancient lava fields and mossy plains. Rivers of molten rock pour across the open ground, consuming everything in their path, blanketing delicate mosses, incinerating low shrubs, and burying the roots of hardy Icelandic grasses beneath a relentless tide of fire. The flow of lava is both destructive and creative, forging new land as it cools and hardens, but leaving behind a stark, blackened expanse where life once thrived. Geothermal vents and hot springs, once teeming with unique microbial life, are sometimes smothered or redirected by the shifting earth, altering the delicate balance of Iceland's geothermal ecosystems. Streams and rivers are dammed or diverted by new rock, changing the flow of water and the habitats of fish and aquatic plants. Birds and small mammals adapted to Iceland's harsh environment must flee or perish as their nesting grounds and burrows are overtaken by the heat and toxic gases of the eruption. Even the air is transformed, thick with volcanic gases and ash that settle on the land, stunting the growth of lichens and wildflowers for years to come. Over time, the cooled lava becomes a new foundation, jagged, glassy, and inhospitable at first, but destined to host the slow return of moss, insects, and eventually birds, as Iceland's resilient natural world begins the long process of renewal. In this dramatic dance between fire and earth, the landscape is forever changed, reminding us that in Iceland the boundary between creation and destruction is as thin and fragile as a crust of cooling lava. Beneath the surface of Iceland's dramatic landscape lies a hidden arsenal, natural defences forged by millennia of volcanic activity and glacial sculpting. These features, silent and stoic, stand as the first line of resistance against the relentless advance of molten rock. Towering volcanic ridges, remnants of eruptions long past, rise abruptly from the earth. Their jagged forms act as natural barricades, channeling and sometimes halting the flow of fresh lava, forcing it to split or slow as it seeks the path of least resistance. Iceland's rivers, born from melting glaciers and ancient springs, carve deep gorges through the volcanic terrain. When lava approaches, these swift icy waters can act as formidable obstacles, cooling, fragmenting, and even redirecting the molten streams in a dramatic clash of fire and ice. Vast fields of solidified lava, some centuries old, create a labyrinth of hardened rock. These ancient flows, with their unpredictable surfaces and deep fissures, can trap or divert new lava, slowing its progress and dispersing its energy across the landscape. Steep basalt cliffs and natural amphitheatres, formed by the collapse of volcanic chambers, present sheer faces that lava cannot easily surmount. These geological fortresses force the molten rock to pool and spread, buying precious time for the land beyond. Beneath the surface, a network of ancient lava tubes and fissures offers hidden channels. Sometimes, new lava finds these underground routes, vanishing from sight only to re-emerge elsewhere, its path dictated by the unseen architecture of the earth. Crater lakes and geothermal pools scattered across the volcanic zones can act as natural traps. When lava meets water, explosive interactions occur. Steam billows, rock shatters, and the advance of the flow is checked, if only for a moment. The broad, gentle slopes of shield volcanoes allow lava to spread thinly over vast distances, dissipating its force and reducing the threat to any single point. This natural diffusion is a subtle but powerful defense, shaping the flow's destiny. Columnar basalt formations with their tightly packed hexagonal pillars create formidable barriers. These geometric walls, born from the slow cooling of ancient lava, stand as silent sentinels, resisting the advance of new flows with their sheer density and strength. In narrow valleys and mountain passes, the land itself forms choke points. Here, the advancing lava is squeezed and slowed, its power diminished by the unyielding embrace of stone. Together, these natural defenses, ridges, rivers, ancient flows, cliffs, tubes, and valleys, compose a suspenseful, ever-changing battlefield. The outcome of each eruption is shaped as much by the land's ancient architecture as by the fury of the volcano itself. The deflection and redirection of lava flows is governed by a complex interplay of natural forces and geological features. In nature, lava does not simply spread out evenly across the land. Instead, its path is shaped by the underlying topography, the presence of water bodies, and the composition and structure of the rocks it encounters. The force of gravity pulls molten rock downslope, causing lava to seek the path of least resistance, often following valleys, depressions, or pre-existing channels carved by earlier flows or erosion. Natural ridges, hills, and elevated terrain act as barriers, deflecting lava sideways and channeling it along lower ground. In volcanic regions, ancient lava flows and solidified rock formations can create natural levees and berms, guiding new eruptions along established paths and away from certain areas. Water bodies, such as rivers, lakes, or wetlands, can also play a significant role in redirecting lava. When lava encounters water, it rapidly cools and solidifies, forming new rock that can block or divert the flow. The interaction between lava and water can result in explosive steam generation, further fragmenting the flow and altering its direction. The type of lava itself influences how it responds to natural obstacles. Pahoho, with its smooth, fluid texture, can travel long distances and easily follow subtle changes in slope, while AA, with its chunky, viscous nature, tends to pile up and form thick, blocky fronts. When encountering steep slopes or abrupt drops, Pahoho may accelerate and spread thinly, while AA may slow down and accumulate, creating natural dams that further redirect subsequent flows. The underlying geology, including the presence of hard, resistant rock layers or softer, erodible sediments, also determines how easily lava can carve new paths or be forced to change direction. In some cases, lava may exploit weaknesses in the ground, such as fractures, faults, or old lava tubes, allowing it to bypass surface obstacles and emerge in unexpected locations. Over time, repeated eruptions and the accumulation of solidified lava reshape the landscape, creating new channels, barriers, and basins that influence the direction of future flows. The dynamic nature of volcanic terrain means that each eruption can alter the topography, sometimes opening new routes for lava or blocking old ones. Even small changes in elevation or the presence of a natural gap can determine whether a flow advances or is halted. Natural breaches, such as those caused by erosion or previous lava activity, can act as weak points, allowing lava to escape containment and find new paths. The interplay between lava and the landscape is a continuous process, with each flow modifying the environment and setting the stage for future eruptions. Fissure systems, which can open in different locations during each eruption, further complicate the pattern of lava movement, as new vents may send flows in entirely new directions. The result is a constantly evolving network of natural channels, levees, and obstacles, each playing a role in deflecting or redirecting the relentless advance of molten rock. The study of these processes provides insight into the behavior of lava and the ways in which the Earth's surface responds to volcanic activity. Observing how lava cools and solidifies on different slopes or how it interacts with water and rock reveals the underlying physics that govern its movement. These observations are used to refine scientific models, improving predictions of future lava flow paths and the potential impact on the landscape. Each natural event, whether a successful redirection or a breach, adds to the understanding of volcanic processes and the forces that shape the land. Ultimately, the deflection and redirection of lava flows is a testament to the dynamic relationship between molten rock and the ever-changing surface of the Earth, sculpted by topography, water, and stone. Beyond the human experience, Iceland's volcanic awakenings leave a profound mark on the island's ecosystems, shaping the very fabric of animal and plant life. When eruptions blanket the land in ash and lava, native animals like the Arctic fox and ptarmigan must adapt quickly, seeking new shelter and food sources as their habitats are transformed overnight. Seabirds, including puffins and guillemots, are forced to adjust their nesting sites, sometimes abandoning old colonies when volcanic gases or ash make the air unbreathable and the ground unstable. Rivers and streams, vital for salmon and trout, can become choked with ash, altering water chemistry and threatening the delicate balance that supports aquatic life. Yet, in the aftermath, nature's resilience is astonishing. Hardy mosses and lichens are often the first to colonize fresh lava, slowly breaking down rock and creating the first thin soils. Over time, birch and willow saplings take root, and wildflowers begin to bloom, transforming barren fields into vibrant new habitats. Grazing animals like Icelandic horses and sheep adapt to the changing landscape, finding nourishment among the new growth that springs from the nutrient-rich volcanic soil. Geothermal areas, warmed by the Earth's heat, become oases for rare plants and insects, supporting life even in the harshest conditions. The process of ecological succession unfolds over decades and centuries, as each eruption resets the clock and life begins anew. Wetlands, formed by the damming of rivers with lava, become crucial stopovers for migratory birds, adding to the island's biodiversity. Some of Iceland's rarest plants and insects thrive only in these unique volcanic environments, their existence tied to the cycles of destruction and renewal. In the quiet after eruption, under the northern lights, the land breathes and recovers, a testament to the enduring power and adaptability of Iceland's wild heart. One of the great paradoxes of Iceland is that the very geological feature that poses such a threat is also one of its greatest gifts. Volcanic activity, while often destructive, plays a vital role in shaping the island's natural environment. Each eruption brings with it a surge of molten rock and ash, which over time transforms the landscape. As lava cools and solidifies, it creates new land, expanding the island's boundaries and forming dramatic geological features. These new lava fields, though initially barren, gradually break down under the forces of wind, rain, and frost. Over years and decades, the volcanic rock weathers into mineral-rich soil. This soil, infused with nutrients from deep within the earth, supports the growth of hardy mosses, grasses, and wildflowers. The process of ecosystem renewal begins as plant life slowly reclaims the land. Over time, these new habitats attract birds, insects, and other wildlife, fostering biodiversity and supporting unique Icelandic ecosystems. Volcanic activity also creates geothermal springs and mineral-rich lakes, which become oases for life and contribute to the island's natural beauty. The warmth from geothermal vents allows for pockets of lush vegetation, even in the harshest climates, supporting life where it might not otherwise exist. Ash from eruptions, though disruptive, eventually settles and enriches the soil, while rivers carry minerals downstream, nourishing valleys and wetlands. Yet, this renewal comes at a cost. Fresh lava flows and ash clouds can devastate existing habitats, smothering vegetation and altering waterways. Rivers may be blocked or redirected, wetlands can dry up, and entire ecosystems may be forced to adapt or relocate. Wildlife must navigate these ever-changing conditions, seeking new shelter and food sources as the land transforms. The cycle of destruction and renewal is constant, demanding resilience from every living thing. In the end, volcanic activity is both a challenge and a blessing for Iceland's natural world. It brings fertile soil, new land, and vibrant ecosystems, but also forces adaptation and change. This dynamic balance shapes the island's unique environment, ensuring that life here is always evolving, always finding new ways to thrive. In the land where fire meets ice, Iceland's ever-changing volcanic landscape stands as a living testament to the power of geological resilience. Here the Earth is in constant motion, shaping, breaking, and rebuilding itself in a cycle that has persisted for millennia. Each eruption, while dramatic, is part of a grand process of renewal. Lava flows harden into new land, and over time, life returns. Mosses, lichens, and hardy plants colonize the barren rock, transforming it into a thriving ecosystem. The resilience of Iceland's ecosystems is a triumph of adaptation. Life here has evolved to withstand extremes, surviving ash falls, acid rains, and the relentless advance of molten rock. Over centuries, these ecosystems have not only endured but flourished, turning adversity into opportunity. The land itself is a dynamic canvas, constantly evolving. Glaciers carve deep valleys only to be filled by lava in the next eruption. New islands emerge from the sea, while old ones are reshaped by the relentless forces beneath the surface. Iceland's geology teaches us that resilience is not about resisting change, but embracing it. The land absorbs each upheaval, adapts and emerges stronger, layer upon layer, eruption after eruption, forging a landscape of unparalleled beauty and strength. The ongoing evolution of Iceland's terrain is a powerful reminder that even in the face of nature's most formidable forces, renewal and adaptation are always possible. The land's triumph is written in every moss-covered lava field, every steaming vent, and every new horizon shaped by fire and ice, from the relentless forging of new ground to the quiet persistence of life reclaiming the land. Iceland's volcanic landscape offers a triumphant blueprint for resilience, adaptation, and the enduring spirit of the natural world. Gap 2. Beneath Iceland's rugged surface, the Earth exhales. Each volcanic eruption releases a complex cocktail of gases, silent, invisible, yet profoundly influential. The most abundant of these is water vapor, but it's the presence of sulfur dioxide, carbon dioxide, hydrogen sulfide, and a trace of other volatile compounds that truly shape Iceland's environment. Gap 2. As magma rises toward the surface, the pressure drops, allowing these gases to escape. Plumes of steam and gas billow from volcanic vents and fissures, carried by the wind across glaciers, valleys, and farmlands. Sulfur dioxide reacts with moisture in the atmosphere, forming fine droplets of sulfuric acid, creating hazy veils known as volcanic smog, or VOG. This phenomenon can stretch for hundreds of kilometers, altering air quality and subtly changing the chemistry of clouds and rainfall. Gap 2. When volcanic gases settle back to the ground, they acidify soils, sometimes stunting plant growth or altering the delicate balance of Iceland's ecosystems. Yet, these same acids can also break down rocks and release vital minerals, enriching the soil over time and fueling the slow return of life to barren lava fields. Gap 2. In water, volcanic gases can dissolve into rivers and lakes, lowering pH and impacting aquatic life. Some geothermal springs become so acidic that only specialized microorganisms can survive, creating unique habitats found nowhere else on Earth. Carbon dioxide, heavier than air, can gather in low-lying areas, forming invisible hazards for wildlife. Gap 2. High above, volcanic gases enter the atmosphere, sometimes reaching the stratosphere. Here they contribute to the formation of aerosols that can reflect sunlight, temporarily cooling the climate on a global scale. These atmospheric changes, though often subtle, are a reminder of the far-reaching influence of Iceland's restless volcanoes. Gap 2. In the end, volcanic gases are both a challenge and a catalyst. They shape Iceland's air, water, and soil, forging new environments and sustaining the cycle of destruction and renewal that defines this land of fire and ice. Gap 2. Deep below Iceland's hardened lava fields lies a hidden labyrinth, a world carved by fire and darkness. These are lava tubes, natural tunnels formed during the most intense moments of a volcanic eruption. As rivers of molten rock surge across the landscape, the outer edges cool and solidify, creating a crust. Beneath this rigid shell, fiery magma continues to flow, hollowing out winding passageways that snake for kilometers beneath the earth. Gap 2. The structure of a lava tube is a testament to the power and precision of volcanic forces. Smooth, glassy walls curve overhead, while delicate formations, known as lava cycles, dangle like stalactites formed from droplets of molten rock. In some places, the floor is rippled, frozen mid-motion in a pattern called pahoho, capturing the flow of ancient lava in stone. Side chambers and skylights, where the roof collapsed or thinned, allow light to pierce the darkness, revealing hidden beauty below. Gap 2. These subterranean corridors are more than geological curiosities. They are ecological sanctuaries. Shielded from Iceland's harsh surface climate, lava tubes provide a stable environment for rare mosses, fungi, and invertebrates that thrive in perpetual twilight. Some species have adapted to the mineral-rich walls, drawing sustenance from the very rocks themselves. Gap 2s. Lava tubes also play a crucial role in the island's hydrology. Rainwater seeps through cracks and fissures, filtering down into these underground channels. Here it is purified and stored, slowly re-emerging as springs that sustain Iceland's rivers and wetlands. In winter, the stable temperatures inside the tubes offer refuge for bats and other small creatures, while in summer they become cool oases amid the sun-warmed plains. Gap 2s. The legacy of each eruption is etched not just on the surface but deep below, where the secret world of lava tubes continues to shape Iceland's ecology, silently connecting the cycles of fire, water, and life. High above Iceland's fiery veins, vast glaciers sprawl across the land, their icy masses draped over sleeping volcanoes. But beneath this tranquil surface, a dramatic confrontation unfolds, a relentless battle between fire and ice. When a volcano erupts beneath a glacier, the searing heat of magma meets the frozen world above, triggering explosive events unique to Iceland's landscape. As molten rock surges upward, it melts the overlying ice at a staggering rate, creating vast chambers of pressurized water trapped beneath the glacier's weight. When the pressure becomes too great, the glacier ruptures, unleashing a jökulhlaup, an immense glacial outburst flood. These floods surge across the plains with little warning, carrying icebergs, ash and debris, reshaping valleys in a matter of hours. Jökulhlaups carve deep channels, deposit thick layers of sediment, and leave behind braided rivers and new landscapes, each marking the site of a violent encounter between volcano and glacier. Subglacial eruptions also sculpt the land in other ways. The rapid cooling of lava beneath ice can form unusual volcanic structures, such as flat-topped tuyas and steep-sided Moberg ridges, geological signatures found nowhere else on Earth. Ash and tephra, trapped in melting ice, settle into thick, dark layers once the glacier retreats, preserving the memory of ancient eruptions within the landscape. Over time, these interactions between glaciers and volcanoes shape Iceland's topography, creating fertile plains, volcanic plateaus, and intricate river systems. The meeting of fire and ice is not just a spectacle, it is a fundamental force that continues to mold the island, forging new land in the crucible of nature's extremes. As the earth trembles and volcanoes roar, a cloud of volcanic ash silently ascends into Iceland's skies. Composed of microscopic shards of glass and pulverized rock, this ash is far more than a fleeting haze. It is a powerful force that shapes the land, air, and water in profound ways. Carried by fierce winds, volcanic ash can travel hundreds, even thousands of kilometers from its source, veiling entire regions in a fine grey dust. In the atmosphere, these particles scatter sunlight, turning day to dusk and painting sunsets in surreal hues of red and orange. The ash clouds drift across the North Atlantic, sometimes disrupting weather patterns and even impacting aviation as engines and instruments face the abrasive onslaught. As ash settles from the air, it coats Iceland's glaciers, rivers and fields in a thin, gritty layer. On ice, the dark ash absorbs sunlight, accelerating melt and altering the timing and flow of glacial rivers. In rivers and lakes, ash increases water turbidity, affecting aquatic life by reducing light penetration and clogging the gills of fish. On land, the ash acts as both a challenge and a gift. It can smother fragile mosses and lichens, temporarily halting plant growth and disrupting the delicate balance of Iceland's ecosystems. Yet, over time, the mineral-rich ash weathers into fertile soil, nurturing hardy grasses and wildflowers that reclaim the land. In the ocean, ash plumes settle onto the surface, providing nutrients that spark blooms of phytoplankton, the foundation of the marine food web. These invisible transformations ripple outward, supporting everything from tiny copepods to great whales. Volcanic ash, though silent and unseen at times, is an enduring presence in Iceland's story. It is a sculptor of landscapes, a catalyst for change, and a testament to the island's restless spirit, forever shaping the air, water, and life that call this land of fire and ice home. Beneath Iceland's rugged surface, a hidden world of minerals is constantly forged in the crucible of volcanic fire. As molten rock cools, an extraordinary array of minerals crystallizes, each with distinct colors, shapes, and properties that quietly shape the island's landscapes. Among the most striking are the jet-black obsidian fields formed from rapidly cooled lava, their glassy shards glinting in the rare sunlight. Obsidian's sharp edges have carved tools for millennia, but its beauty also lies in the way it reflects Iceland's stark, otherworldly light. Elsewhere, vivid green olivine crystals, sometimes called Icelandic peridot, dot the basaltic plains, their grains sparkling underfoot. Olivine's presence not only colors the earth but also strengthens the volcanic rocks, resisting erosion and lending the land its jagged resilience. In geothermal regions, steaming vents deposit crusts of sulfur, painting the ground in brilliant yellows and releasing a pungent scent that signals the restless chemistry below. Deep within lava tubes and fissures, zeolites grow in intricate clusters, delicate, translucent minerals that act as natural filters, purifying water as it seeps through volcanic stone. These zeolites, with their porous structure, support life in unexpected places by trapping moisture and nutrients in an otherwise barren environment. Even the iron-rich hematite and magnetite found in ancient lava flows play a silent role, lending a rusty red to the highland deserts and subtly influencing the magnetic character of the rocks beneath travelers' feet. Over centuries, these minerals break down and mingle, creating new soils that nurture Iceland's grasses, mosses, and wildflowers. The minerals' chemical signatures linger in every stream and valley, subtly shaping the growth of plants and the flow of water. From shimmering crystals to sturdy bedrock, Iceland's volcanic minerals are more than geological curiosities. They are the silent architects of the land, sculpting its contours and coloring its wild, ever-changing face.